In this video, we'll be solving this differential equation. So first we're going to solve it using separable equations. So right now we have x times dy over dx plus y equals y squared. The idea is to move all the y's on one side and all the x's on the other. So in order to do that, we're going to multiply both sides by dx. So right now we have x dy plus y dx equals y squared dx. So as you can see, the dx's have y's as the coefficient. So let's bring the y dx to the right and factor out the dx. And so what we have to do is move the x with the dx, the y's with the dy's. So we're going to divide both sides to get dy over y squared minus y is equal to dx over x. And integrating this, we can use a partial fraction decomposition, but I'm going to skip all those steps. So you can split up the fraction 1 over y squared minus y as 1 over y minus 1 minus 1 over y. The integral of dx over x is ln of x plus c. Integrating the left side, we get ln of y minus 1 minus ln of y. Now we can combine these using the log properties. We can have ln of y minus 1 over y equals ln of x plus c. So the goal is to solve for y, which means we have to do e to both sides, e to the power ln of y minus 1 over y, and e to ln of x plus c. Now in general, e to the ln of x, the e in the natural log will cancel. So really, what's left is what's inside the natural log. But here, because we have a constant, you want to think of this as e to ln absolute value of x times e to the c. And this is just a constant. So this one I just called it a just to keep it simple. So we have y minus 1 over y equals a times x. I'm going to multiply both sides by y. Or actually, before I do that, I'm going to subtract, or break up the fraction rather. Y minus 1 over y becomes y over y minus 1 over y. And then I'm going to subtract ax to both sides, add 1 over y to both sides, and then I'm going to flip both sides. So I have y equals 1 over 1 minus ax. Now I want to use the initial condition that when x is 1, y is 1/2. Plug it in. Because the numerators are the same, I just set the denominators equal to each other. And I get that a is negative 1. And so my solution is y equals 1 over 1 plus x. Now I'm going to solve this a different way. So for a Bernoulli Ode, we have y to negative n times y prime plus p of x times y raised to the 1 minus n power equals q of x, where v is equal to y raised to the 1 minus n power, and v prime is 1 minus n times y to the negative n times y prime. So the goal is to get it in that form, and so for the whatever's in front of y prime has to be y to negative n. So you need to get rid of this x and do y to some power. So the way we're going to do this is get rid of the x by dividing x to both sides, and then we're going to divide by y squared as well, because the right side of this equality has to be a function of x. Right now it's a function of y. So by getting rid of the y squared, we have a function of x, right? So y squared divided by y squared is 1, and then we're also dividing it by x. So now this is a function of x. And so since we have y squared in the bottom, we have y to negative 2 power times dy over dx plus 1 over x times 1 over y equals 1 over x. And here, to get in this form, I should have said that this is y to the negative first power. So if you want to solve for n, that means you have to set 1 minus n equal to negative 1. And adding 1 to both sides, we get 2 minus n equals 0. So 2 is equal to n. So then v will be y to the 1 minus 2 power, which is y to negative 1. Okay, so that's what we have here. So v prime is the derivative of y to negative 1. You can use this formula if you want, or just take the derivative. And so you get negative 1 over y squared times y prime. So we're going to replace that now. So we have negative v prime plus 1 over x times v equals 1 over x. Because here you have 1 over y times 1 over x. This thing is v. And here we have 1 over y squared times dy over dx. That's what we have here. So here we have v prime equals negative 1 over y squared times y prime, which is the same thing as this, but except we have a positive here, so you have to multiply both sides by a negative to get 1 over y squared times y prime. So that's what we have. Okay, so what I did was I multiplied both sides by negative 1, and now I want to figure out the integration factor. So we'll call that mu is e raised to the integral of negative 1 over x dx, which is just e to negative ln of x, which is 1 over x. And so this is what we're going to multiply both sides of this equation to get in this form. And now the left side is just a product rule of derivative of v times 1 over x. And so integrating both sides, the integral and the derivative cancel. So we just have v times 1 over x, and then the antiderivative negative 1 over x squared is 1 over x. Now I can multiply both sides by x to get v equals 1 plus cx. And remember, v we said was 1 over y. So to get y here, I'm just going to flip both sides. Now I have to work with this initial condition. X is equal to 1, y equals to 1/2. And so we get c is 1. And so the final answer is y equals 1 over 1 plus x.